Welcome back, guys. We're back on Brilliant.org. Today I wanted to go over properties of triangles in this section. Triangles are a really important part of geometry and mathematics in general, and understanding their properties is key to success. Alright, let's get started. So we're going to do the lightning warm-ups first. Let's look at this shape. What is the value of x? Alright, so there's a lot to unpack here in this first problem. Well, lots to know. So first of all, if you don't already know, a triangle's interior angles, all three angles, must add up to, they sum to 180 degrees. That's a really important fact. And also, a flat line, if you don't know already, this angle measure of a flat line is also equal to 180 degrees. These are two key facts important to know to solve angle problems. So how can we solve for angle x? Okay, so again, a flat line is 180 degrees. And so what three angle measures are making up this line? We have this 90 degree, we have this 20 degree, and then we have this missing angle. So in math terms, we have 90 plus 20 plus our unknown equals 180. So 90 plus 20 is 110. 180 minus 110 is 70. So x equals 70. So this angle here is 70 degrees. Now again, the interior angles of a triangle must sum to 180. What else do we know? Well, this triangle, we see that this side is equivalent to this side. So this is what we call an isosceles triangle. This is an isosceles triangle, and an important thing about isosceles triangles is these angle measures are equivalent. So this 70 degrees is equivalent to this side, so this side must also be 70 degrees. And because all interior angles of a triangle sum to 180, what does that leave us with? Well, we have 70 plus 70 plus our x equals 180. 70 plus 70 is 140. Subtract 180 from 140, and we're left with x equals 40. So x is 40. Submit. Awesome. Great work. What is the value of p? So similar to last problem, we have lots of isosceles triangles here. We have this isosceles triangle, and so what do we know? What did we just learn in the previous problem? Well, this angle here must also be 30 degrees. And again, a flat line is 180 degrees. So this whole thing is made up of this 30 degree angle and this missing angle here. And the two combined need to sum to 180. So we have our 30 degrees plus our missing angle equals 180. And so this green, this missing angle, must be equivalent to 150, as 180 minus 30 is 150. And now we're left with two angles. We're left with P of this triangle and this opposite side. Well, this triangle here, this one I'm outlining in red, is also isosceles. As we see, this side is equivalent to this side. So what do we know? Well, we know the interior angles of a triangle sum to 180. So we have 180 equals our green, our 150, plus our P here And then this angle is equivalent to p. So let's just add another p. We simplify to solve. We can subtract 150 from both sides, and we're left with 30 equals 2p. And then we divide by 2, and we get 15 is equivalent to p. So p equals 15. Awesome. What does this problem say? If a triangle's height is doubled and its base length is halved, the area of the triangle will... Okay, what will happen? So first of all, how do we find the area of a triangle? The area of a triangle is base times height divided by 2. And if you're wondering how I got this formula, it's actually quite simple. It's, as we know, an area of a rectangle or quadrilateral is your base times your height. And then where does this divide 2 come from? Well, the divide 2 is simply, well, if we cut our rectangle in half, we're left with 2 identical triangles. So that's how we got the formula base times height divided by 2 for area of a triangle. Alright, so back to the problem. If a triangle's height is doubled and base is halved, the area will what? So let's make a couple example triangles. It's always good to make examples with real numbers whenever asked about a question not involving any sort of numbers. So this triangle, what's its area? Well, its base is 2, its height is 2, and we divide by 2, and we get 2. Then what if we make a triangle as described? Its height is doubled, so 4, its base is half, so 1, and we're left with what? 1 times 4 divided by 2, and this also equals 2. So the area will stay the same. What is the area of this triangle? So this is checking to know if you know if these little lines here, these indicate that the side lengths are equivalent. And so this side must also be 10. So it's also maybe checking if you know how to turn the triangle visually. If we turn this triangle on its side, it would look like this. And we'll have 10 and 10 and our right angle here. And so this is the base and this is the height, right? If you could also find the area if you knew this whole length and this height. You could find the area. However, this is much simpler, and I hope you see that. So again, the area for a triangle is base times height divided by 2. So this is 10 times 10 divided by 2. 10 times 10 is 100, divided by 2 is 50. So the area of this triangle is 50. Oops. Let's see what this problem says. If the area of the small red triangle is 12, what is the area of the larger blue triangle? Alright, so here's the picture more zoomed in. The area of the red triangle is 12. So let's go to red for red triangle. So again, we know that base times height divided by 2 is our area, and we know our area in this case is 12. We have our height to be at a value of 2, but we do not know our base length. Our base length is unknown. We see our base length is unknown for both the red and the blue triangles, and our base lengths are the same. So we know the height of the red triangle is 2, And we know the height of our blue triangle is what? It is 4. Alright, so let's go back. So how can we solve this problem? Well, again, we have base times height. Here, let me go to my red, as we're solving for the red triangle. Alright, so we have base times height divided by 2 equals 12. And then what? We know our height is 2, so we have base times 2 divided by 2 equals 12. And now we can solve for b. Well, these 2's just cancel, and so we have our base equals 12. So what is the area of the larger blue triangle? Well, again, our base is the same for both triangles. So our base for the blue triangle is 12 times its height, which is 4, and then we divide by 2 to get our answer. 12 times 4 is 48, divided by 2 is 24. Did I accidentally click the answer earlier? Oh, well, I didn't even realize I did that. But yes, the answer is 24. Huh. Alright, well, good work, guys. That's the lightning quiz for properties of triangles. In the next video, we'll do the sum of angles questions, and then future videos, we'll do the challenge quizzes. Take care, guys. See you in the next video.